Welcome to this explainer. Okay, so have you ever looked at a page just absolutely stuffed with gigantic numbers? You know, the ones with commas and decimals that seem to go on literally forever? And your stomach just kind of does a little flip? Well, you are definitely not alone. Those big numbers can look super intimidating. But today, we're going to open up a magical book that turns those giant, scary math monsters into friendly, fluffy pets. We're going to make taming those numbers as simple and fun as playing in a sandbox.
Imagine you've got this secret spell book. When you have a really massive pile of toys to count, or a giant multiplication problem that just looks way too scary to even try, this book does all the heavy lifting for you. See, before we all had calculators in our pockets, people used this exact kind of magic trick. It literally turns hard, messy, complicated multiplication into simple, easy addition. It's exactly like taking those giant math problems and just stacking building blocks on top of each other one by one. It makes the impossible feel incredibly easy. So let's take a peek inside this magic book. Imagine we have a pretty big number toy, something like 184. Instead of doing hard math with it, we just flip open our book, find the number 184, and right next to it is a special magic spell. Now, grown-ups call this a logarithm, or a logarithm table. But really, instead of writing out that big old 184, our book tells us its secret magical name is 2.26482. By using these smaller, simpler magic spells instead of the giant, clunky numbers, we can solve big puzzles so much faster and with way less work.
And here's where it gets really fun. We can play a game called a reverse lookup. Think of it exactly like a game of hide and seek. Sometimes, we already know the magic spell, like 1.47384, but we want to figure out exactly which toy is hiding behind it. To do that, we literally just read the book backwards. We search through the pages for that exact spell, scanning line by line, and poof, we find the hidden number toy, which in this case is 29.7743. It's basically a magical treasure hunt that works beautifully in both directions.
Now, we absolutely have to talk about the most important, most magical number in our whole math playground. Any guesses? It's the number 10. Everything in our storybook, every single spell we use is built right around this specific number. When we ask for a logarithm, we're really just asking a tiny invisible machine a very simple question. We're asking, how many times do I multiply 10 by itself to get my toy? 10 is absolutely the boss of this playground. It sets all the rules.
Okay, so sometimes in math, negative numbers can be a little grumpy and, frankly, hard to play with. But these old magic books found an incredibly clever way around them, using something called an arithmetic complement, which is really just a fancy grown-up way of saying we're finding the missing puzzle piece that fits perfectly to make exactly 10. So, if our spell on one side is 3.44138, we just ask a simple question, what piece do we add to reach a perfect 10? The answer is 6.55862. You just snap them together, they make exactly 10, and those grumpy negative numbers stay far away.
Moving on, sometimes we run into a reciprocal. Now that's just a giant, funny word for turning our number toy totally upside down. If your number's a fraction, a reciprocal just flips it right over. It's literally exactly like taking a regular toy block and making it stand on its head. It's the exact same toy, just looking at the world from a completely upside-down point of view.
And here is absolutely the coolest part of our magic book. An upside-down number always gets the exact same missing puzzle piece we just talked about. If you turn a number into its reciprocal, its magic spell magically becomes the arithmetic complement. Upside-down toys and missing puzzle pieces always go hand in hand. This is huge because it saves us so much time and effort. We don't have to go learn some brand new spell, we just find the exact piece that makes a perfect tap. Now let's meet some new friends in a really fun part of the playground called trigonometry. These friends always come in pairs, like sine and cosecant. They play together all day holding hands tight. And why are they so close? Well, it's because they are exact upside-down versions of each other. They're reciprocals. Wherever sine goes, cosecant is right there standing on its head. And because they're best friends, they share trigonometric log complements. Basically, their magic numbers always add up to our perfect puzzle piece of 10. If sine's magic spell is 9.57928, cosecant doesn't need to go out and find a totally random new spell. Since they're upside-down versions of each other, cosecant just takes the missing puzzle piece, 0.42072. You add them up, and boom, a perfect 10. They always balance each other out completely. Now, as we're reading our book, sometimes you're going to see a tiny secret line floating right above the number 5 at the very end of a spell. It almost looks like a tiny magic wand casting a little shadow. This dash is a special warning sign.
It tells us to pay very close attention to our next step before we make our numbers shorter. It's a secret code that helps us know exactly how to play fair.
That magic wand tells us how to play a really simple game called rounding, where we decide whether our number stays perfectly still or takes a big step up. It's so easy. If the next number in line is a tiny 0, 1, 2, 3, or 4, you leave your number completely alone. Stay right there, don't move. But if the next number is a big 5, 6, 7, 8, or 9, you take one giant step up and make your number bigger by 1.
But wait, what if our number toy has a whole bunch of extra digits and it isn't printed perfectly in the magic book? Like, maybe the book just skipped right over it. Well, for that we have to use a big grown-up word called interpolation. But seriously, don't let the big word fool you for a second. Think of it exactly like guessing where a toy car parked when it stops right in the absolute middle of two big, bold lines on a ruler.
Let's say we have the number 168.342. Our book might only show the starting line for 168.3 and the finish line for 168.4. Our exact number is missing, but by using interpolation, we can guess exactly where our car stopped based on how far it drove between those two lines. We just figure out the total distance between the two spells we do have and add a tiny little fraction of it to our start line. So we basically get to fill in the missing gaps all by ourselves.
Now, our playground also has some very, very small toys. We're talking super tiny angles here, like a small angle sine or tangent. Because they're so tiny, almost microscopic, and hard to see, our normal spells get a little bit confused. They're just too small for the regular magic. So our book has a special trick. We just add tiny little correction numbers, secretly called S and T, to help them out. We take the spell for the tiny angle, add the S or T correction, and just watch the magic fix the number perfectly so it grows up just right.
So, we learned earlier that the absolute coolest trick of this book is turning really hard multiplication into super easy addition. But what if we just want to do normal addition, like adding A plus B? Well, normally, the magic rule says there is simply no rule for that. You can't just take their spells and add them together. But don't worry. When our normal magic fails us, our storybook has secret pages hidden in the very back, called addition and subtraction tables, to save the day. You just look them up in a special section designed exactly for plain old adding and subtracting. When you step back and look at everything we've covered today, the big secret is right here. All these big, scary words, logarithms, mantisses, characteristics, interpolation, they're really just fun, secret power of 10 names for numbers. They're basically magical nicknames that make heavy, terrifying math feel as light as a feather. By giving hard numbers a simple name, we transform scary multiplication into friendly addition and messy division into simple subtraction.
So, if we can turn giant, terrifying math monsters into easy puzzles just by using a magic book, what other amazing adventures can numbers take us on next? Think about your own life. What other incredibly complicated problems could become perfectly simple just by looking at them from a totally new perspective, or maybe giving them a new magical name? Keep looking for those hidden magic storybooks in the world around you. Thanks for exploring this one with me.